So let's think through a scenario. Suppose that we have a region of space that has, and you'll notice I have 3, 6, total of 10 molecules over here. And over here I've got 1, 2, 3, 4, 5 molecules. So 10 and 5 molecules. And they're both in the same amount of space. Which one of those is going to be at a higher pressure? Well, intuitively, you're probably going to say, well, the one that has more atoms or molecules is probably the one with the higher pressure. And you're right. But we want to make sure we take it one step further to understand why. Now, let's put it into motion so we can have that help us. The key thing is that we have to have our energy be conserved. If we have more collisions, we're going to be having more force. Now imagine that we got this thin wall here. All those molecules are on this side, fewer molecules on this side. We put them into motion, and let's just say that they're at the same temperature right now, so they have the same amount of kinetic energy. They're moving at about the same speeds. What's happening right now is that I've got something like 4 molecules crashing into the wall, and over here I've got something like 2 molecules crashing into the wall at any given moment. And of course, it's much more chaotic than this, but it's a good visual for us to just start with, right? Well, because energy has to be conserved, notice that we're going to have twice as much force on this side hitting it as we had on this side. As a result, I'm expecting that this wall is going to move over. And it's going to move over until finally it's got the same number of collisions happening. So if I move that over to here, and all 5 of those balls were crashing onto it from this side now, I'd probably have them hitting into it just as often now as the molecules on the other side. That is what we're really talking about with pressure. Now, that means it's going to press them over to one side. We can actually do a neat little experiment with this. We can actually heat up a gas can. You can see here it was an alcoholic can of some sort. You can actually heat it up, and when you cool it, or if you pump out the volume, either way, what's going to end up happening is if there's an imbalance of the amount of molecules on the inside banging against the wall, and there's more molecules on the outside banging against the wall, overall the collisions are bigger on the outside. It will press the thin wall inward, crumpling that gas can. That's what we're going to have happen whenever we have pressure where it's too low on one side and high on the other, and where the wall between the two is thin enough that it can actually be forced to move by all these tiny little collisions that are happening. You can think of it as small little jackhammers beating on each side of this wall, and you have to move it back and forth until finally the jackhammers are hitting just as often on both sides of the wall. That's what's going on with pressure at the micro scale.